All right, let's talk about climate change. I mean, you hear that phrase everywhere, right? But what does it really mean deep down? We're going to break it all down. Think of it in four parts. First, what's actually happening out there? Second, what's behind it all? Third, and this is the big one, why should you even care? And finally, what's the game plan? But before we get into any of that, let's start with just one single number. Okay, here it is, 1.5 degrees Celsius. Everything, and I mean everything we're about to talk about, comes back to this one number. Since we really kicked the Industrial Revolution into high gear, that's how much the average temperature on our planet's surface has gone up. It's kind of like the Earth is running a low-grade fever. Now, I know what you're thinking, 1.5 degrees, that's it? But trust me, that small number is the first clue, the key symptom that points to something much, much bigger. So for part one, let's look at the evidence. We're calling this a planet getting warmer. What are the signs that scientists are actually seeing? First things first, let's clear something up that trips a lot of people up. You hear the terms global warming and climate change thrown around, sometimes like they're the same thing. They're not. Think of it like this. Global warming is the fever. It's that 1.5-degree temperature increase we just talked about. It's the symptom. Climate change is the full diagnosis. It's the fever plus all the other effects that come with it. You know, the weird weather, the melting ice, the whole shebang. And believe me, there are a lot of other effects. That little bit of extra heat is doing some major work. It's causing glaciers and massive ice sheets to shrink, which you can see from space. It's loading the atmosphere with more moisture, which then comes down as heavier rain. And nature is definitely noticing. We're seeing plants bloom way earlier than they used to, and animals are literally on the move, trying to find cooler spots to hang out. Now, this warming isn't spread out evenly, not at all. The Arctic is getting hit way harder, warming up about 3, even 4 times faster than the global average. And this sets off a really dangerous chain reaction. See, that bright white ice acts like a giant mirror, reflecting the sun's heat back into space. But as it melts, it uncovers the dark ocean beneath it. And dark surfaces absorb heat, which melts more ice, which reveals more dark ocean. You get the picture. It's a feedback loop that's accelerating the whole process. Okay, so we've seen the symptoms. The planet has a fever, and it's causing all sorts of changes. So now for part two, the diagnosis, the human fingerprint. What or who is really driving all this? To get to the bottom of this, we have to talk about something called the greenhouse effect. And here's the thing, it's not a bad thing. In fact, it's essential for life. You can think of our atmosphere as having this perfect invisible blanket around it. It lets the sunshine in to warm us up, and then it traps just enough of that heat to keep Earth from being a frozen wasteland. It's what makes our planet so livable. So the blanket itself isn't the problem. The problem is we've been making that blanket thicker, a lot thicker. We're pumping extra heat-trapping gases into the air, and the number one offender here is carbon dioxide, CO2. It accounts for a whopping 75% of the problem, and most of that comes from burning fossil fuels for energy. And if you need a smoking gun, this chart is basically it. This is the scientific fingerprint. Researchers have looked at everything. Could it be the sun getting hotter? Nope, the data shows its effect is tiny. What about other kinds of pollution, like aerosols? Well, they actually have a small cooling effect. When you run the numbers, the only thing that perfectly matches the warming we're observing is that huge spike in greenhouse gases. That is the human fingerprint, clear as day. So, we've got the symptoms and we've got the cause. Now for part three, the prognosis. What happens when you keep thickening that atmospheric blanket? Let's talk about the ripple effects. And these ripples spread everywhere. All that extra trapped heat is basically just energy, and it has to go somewhere. On land, it fuels bigger deserts, more punishing heat waves, and the kinds of wildfires we've been seeing. In the ocean, where most of the heat has actually been absorbed, it's causing sea levels to rise and changing the actual chemistry of the water, making it more acidic. And in the air, that energy is supercharging our weather, leading to more powerful storms and more severe droughts. It's all connected. And of course, these environmental impacts slam right into human society. This isn't some abstract problem happening out there. This is about our food and water supplies becoming less secure. It's about our homes and our roads being damaged, costing billions. It's about people having to leave their homes because it's no longer safe or possible to live there. And the tough truth is that these impacts always hit the poorest and most disadvantaged communities the hardest. That's why this matters. You don't have to take my word for it. The Intergovernmental Panel on Climate Change, which is basically the world's most authoritative group of climate scientists, they put it pretty bluntly. They said that what we're doing could have severe, pervasive, and irreversible impacts. Now, scientists don't usually talk like that. When they use words that strong, it's a five-alarm fire. So, that's a pretty heavy diagnosis. What's the treatment plan? That brings us to our final section, the pathways to the future. When you look at the global conversation, it really all comes down to two big ideas.
Those two big ideas are mitigation and adaptation. Think of it this way. Mitigation is about fighting the disease itself. It's all the stuff we do to stop pumping greenhouse gases into the air, to get at the root of the problem. Adaptation, on the other hand, is about learning to live with the symptoms we already have. It's about adjusting to the changes that are already baked in. And spoiler alert, we have to do both.
So, what does mitigation actually look like? Well, it's the big stuff. It means a massive shift in how we get our power, moving from fossil fuels to clean sources like solar and wind. It means getting way smarter about how we use energy, so we just waste less of it. It also means protecting and even replanting forests, which are amazing at sucking carbon out of the air. And it means totally rethinking how our industries and our farms operate. And then there's adaptation. This is the practical, boots-on-the-ground stuff to prepare for the new reality. We're talking about things like building higher seawalls for coastal cities, engineering crops that can survive with less water, setting up better warning systems so people know when a huge storm is coming. It's even things like installing green roofs on city buildings to help with cooling, or restoring natural defenses like mangrove forests to protect our coastlines.
So, what's the goal of all this work? Well, the world actually has one. Back in 2015, just about every country on the planet signed what's known as the Paris Agreement. They all agreed to a common target, to keep the planet's warming well under 2 degrees Celsius, while trying their best to stay below that 1.5-degree mark we started with. And this right here is the cliffhanger. This is the big question. The world has promised to aim for well under 2 degrees. But the reality? Based on all the policies that are actually in place right now, we're headed for something closer to 2.8 degrees. That's a pretty big gap between what we promised and where we're actually going. And so the question that's going to define our future is a simple one. What are we going to do to close that gap?